Hello and welcome to my channel. In this channel, we explore statistics in architectural research. I am Dr. Louis Jas.
The Latin square design is one of the experimental design that we use in architectural research. So, in this Latin square design, we use it once you observe the variation. Once you observe the variation between the experimental units. Experimental units, remember, that is where the treatment will be applied. So once you observe the variation on those experimental units, we have to think of the Latin square design. We have to use Latin square design only when we observe the variation into two factors. Once we observe the variation into two factors, we use the Latin square. Remember, if it's only one factor, that's where now we think of the completely randomized block design. But now if it's two factors, we have to block into two. Once you block into two, that particular design, we call it as a Latin square design. Now, this is the field. In this field, we are going to separate into rows and you separate into columns, right? So we can have this layout. In this layout, we are saying we have our treatment. We have treatment A, B, C, and D. We have these four treatments. We want to test the effect of these four treatments on our trait of interest. For example, you want to test the effect of these four treatments on the growth performance of the animal, for example. Now, you arrange your experimental units, you arrange them into rows, you arrange them into column rather, the columns, and you arrange them into rows. We have row 1, 2, 3, 4. You have column 1, we have column 1, 2, 3, and 4. Now, you have to make sure that you put your treatment, you assigned your treatment in these pens. If it's the animal science experiment, you assign this treatment randomly. We can put A, we put B, C, D, right? We just put them randomly. Now, on the second row, we can put B here, we put A here, we put D here, we put C, right? Then we go to the other row number 3. We can put C here, we put D here, we put A, we put B, right? Now, when you are using the Latin square design, you have to make sure that each treatment is appearing once per column. Each treatment is appearing once per row. Now, we have to look at this first column, right? The first column, we have to see which treatment is not appearing here. You can see we have treatment A, B, C, but we don't have treatment D, right? We go to the second column. The second column there, we have treatment A, B, D, but we don't have C. We go to the third column, we have A, C, D, we don't have B, right? Then the last one, of course, you have to make sure that all of them, they appear. It's the same as the last row, all of them, they appear. So you can see here, what is not appearing is treatment A. So when you are applying the Latin square design, even if maybe let's give the example of the plant sciences, whereby you want to see the effect of these 4 fertilizers on planting. You want to plant, you go to your field. When you arrive at the field, you find out there is a variation on the field. You can see the variation. So before you plant, you have to apply the Latin square design. If the variation that you observe is coming with two vectors. You can see the variation in two vectors in your plots. So now you have to divide your plot into two. You divide your plot into rows and you divide your plot into columns. And when you apply now those treatments on those plots, you have to make sure that you apply them randomly. But each and every treatment is appearing once per row and once per column, so that when you want to know the effect of treatment, for example in this column, right, you want to know the effect in this column, you have to make sure that all the treatments are there. You can see the performance of A, B, C, D in this column. It's the same if you want to know in this row. You want to know the effect of your treatment in this row, you can observe the performance of A, B, C, D, all of them, they are there. So in Latin squared design, we have to make sure that once you observe two variations in your experimental units, we always emphasize by saying the experimental unit is nothing but is where the treatment will be applied. Once you see that variation into two vectors, you have to apply the Latin squared design. In Latin squared design, like the other designs, we have the assumptions, right? So our assumptions of the experimental design. The first assumption that we have here is homogeneity. We have homogeneity. What are we saying here is the homogeneity within the experimental units in a row, experimental units in a column, right? We have the homogeneity. As I emphasize, we have homogeneity of the experimental units. We have to make sure that in these experimental units within a row, they are homogeneous, they are similar, right? Their condition is the same. So that once you observe the performance of the treatment, you will assume that that performance is because of the treatment, not because of the variation on the experimental units. That's why we are saying that you have to make sure that the experimental units within a row, they are similar. The experimental units within a column, they are similar. In this column, make sure they are similar. In this row, make sure they are similar. This is the assumption of these experimental units, of this experimental design. Then the other assumption that we have here is within a row, we have to make sure that the number of treatments are the same or are equal, right? The number of treatments are equal, right? In this column and in this column, the number of treatments are equal, and also each treatment is appearing once per row, is appearing once per column. That is the other assumption that we have. Then we also have the limitations, right? Like the other limitations, like the other experimental designs. The Latin squared design, we also have the limitations. One of the common limitation in this experimental design is always difficult to lay out your treatments once we have many of them. It's always difficult when we have many, once we have many treatments. Once we have many treatments, it's always difficult to put the layout of the Latin squared design. But if we have few treatments, it will be easy just to put those treatments. Why is always difficult when you have more treatments? It's because you have to make sure that you meet the assumptions. You have to make sure that each treatment is appearing once per row, once per column. You have to make sure that there's homogeneity within a row, right? There's homogeneity within a column. Latin squared design, we do have general linear model like the other designs. General linear model. Yijk is equal to the mu plus the row effect plus the column effect plus the treatment effect plus the error, IJK error. Now, in this model, you have to know that YIJK is nothing but the response of your trait, right? If you want to know the effect of the treatment on the growth performance of the animal, so is that growth performance, the effect of the growth performance in the row I into the column J of the K treatment, right? Of the K treatment, the treatment K. So now what I'm trying to say is that the YIJK is nothing but the response. Remember, you will be collecting your data from the row, collecting your data from the column, experimental units, and the data of the treatment. So it's the response of the treatment, response of the trait of your interest on row I, column J, and the treatment K. Right. Now it will depend which column, which row, and which treatment where you are collecting your data. Now, the mu is nothing but the overall mean, right? Then we also have R I is equal to the effect of the row. Remember, when we were making our layout, we have the rows and the columns. So the Ri is the effect of the row. Then the Cj is the effect of the column, right? Is the effect of the column. When you are analyzing your data, you have to apply this model so that you can see whether is there any effect of a column, is there any effect of a row. Then the last one, which is the TK. The TK, that is the main effect because it's the effect of the treatment. That is your interest. The effect of the treatment. The effect of the treatment. Then the last one, we have the error. As we all know that when we are doing our experiment, we have the error. Then we call it as a residual error. Residual error. So this is the general linear model that we have to apply when we analyze our data for the Latin square design. So recap, we have covered the Latin square design. In this design, all the experimental units are similar within a row and also within a column.
Do you have a topic you'd like me to cover, a question, and maybe you want a clarity on a certain topic? Leave a comment below. Do not forget to subscribe, like, and share this video.
See you in the next one.